Welcome guys. In this video we are going to focus on a circuit connected in parallel. Now we are going to have two diagrams. The first diagram will have two resistors, the second one will have three resistors. So let's have the first diagram. So from the first video, I'm sure you remember we looked at the electrical symbols that I used, and you need to make sure that you know these electrical symbols. Like here, this is a battery source where we said the longer side represents the positive terminal, the smaller one represents the negative terminal. Now under this circuit, I'm going to call this one as my total voltage source. So this is where the voltage is produced, and this voltage produced here is the total. Now before we look at the voltage, now let's first include the resistor. So I'm going to call this one as resistor 1, then this is my resistor 2. Now what I want us to understand is how much of voltage will pass through resistor 1 and resistor 2 as long as our circuit is connected in parallel. So let's look at the voltage. So voltage is constant as long as the circuit is in parallel. If not constant, we use the word same. So what do I mean by this statement? So I'm going to call the voltage from resistor 1 as our voltage 1, then from this one as our voltage 2. So what this simply means is that the total voltage is equal to voltage 1 equal to voltage 2, which simply means that if 10 volts is produced by the source, the same 10 volts will pass through resistor 1 and resistor 2 respectively. So that is in terms of voltage. So this is the same as even if you have 3 resistors or 3 or 4 resistors. So regardless of the number of resistors, as long as the resistors are connected in parallel, voltage is equal at all points. Now let's move on to current. What of current? So I'm going to say here I have my total current. Then the one passing through resistor 1, we'll call it current 1. Resistor 2, we'll call it current 2. Now, is total current equal to current 1 or current 2? No. For this one, we are going to say total current is the sum of current 1 and current 2. So that's what you're supposed to know. So you just have to say current 1 plus current 2. So if you can find current 1 and current 2, and if you add those two numbers, you can have the total current produced by the circuit. What of power? So power is similar to current. So I'm going to say total power, which is produced by the source here, is equal to power 1 plus power 2. Now let's have a look at a circuit where we have 3 resistors. So the same, first I'm going to put resistors. So I'm going to call this is resistor 1, resistor 2, resistor 3. Then let's look at the voltage. So if you remember, we said voltage is constant. So if this is my VT, V1, V2, V3. So VT is equal to V1 equals V2 equals V3. What of current? So the total current IT will be equal to current 1 plus current 2 plus current 3. Let's look at the power. For power, we'll say PT, total power, will be equal to power 1 plus power 2 plus power 3. Okay, now let's go back to our first diagram. So for the first diagram, now let's look at how do we find the total resistors. So the total resistors can be found by this formula. So 1 over RT is equal to 1 over R1 plus 1 over R2. Or if you want, we can also use this one. So total resistance is equal to resistor 1 times resistor 2 divided by resistor 1 plus resistor 2. What of the one connected with 3 resistors? So with 3 resistors, we are just going to have the same formula, but to reach at resistor 3. So what I mean is 1 over R2 is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Or if you want, we can say RT is equal to R1 times R2 times R3 over, you just add these 3 resistors. If you want, you can also use this one. You can just say RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Then raise to the power negative 1. So you can still get the same answers. Now let's look at the first example. So the first example, I'm going to have a circuit diagram with 2 resistors. Okay, so I'm going to have my 24 volts as my power source, then 6 ohms resistor and 4 ohms resistors. Now the first question, we are going to find the total resistors, so the combined resistance for the 2 resistors. So that is our first question. So we said 1 over RT is equal to 1 over R1 plus 1 over R2. 1 over RT is equal to 1 over, so this one will be my resistor 1, my resistor 2. So I'm going to say resistor 1 is 6 plus 1 over 4. So we just have to find the lowest common denominator. So the lowest common denominator for 6 and 4 is just 12. 6 into 12 is 2 times 1 is 2 plus 4 into 12. 4 into 12 is just 3 times 1, 3. So 1 over RT is equal to 5 over 12. So we cross multiply 5 RT. You just give us 5 RT. Then 1 times 12 is just 12. So we divide by 5. We divide by 5. RT is equal to 2.4 ohms as our total resistors. So if we were to show this diagrammatically, it means that the 2 resistors have been combined to form 1. So that's what it means by the total resistance. So here we still have 24. Then our new resistance is 2.4 ohms. Now let's not focus on this part here. I just wanted you to have a picture what we are looking at. Now we can also find the same answer by using this formula. So we'll say RT is equal to resistor 1 times resistor 2 over resistor 1 plus resistor 2. So resistor 1 is 6 plus times 4 over 10. Where is 10 coming from? We just add 6 plus 4. 6 times 4 is 24 over 10. So 24 divided by 10, we still get the same answer, 2.4 ohms. So this is our total resistors, 2.4. Now from there, let's find the current across each resistor. So what do I mean by that? Let's find the current that went through resistor 1. So to find current, we need to use the formula from the Ohm's law. So we'll say current is equal to voltage over resistance. Now since I'm looking for the current in resistor 1, I'm going to call this one as my current 1. Then this will be my resistor 1. Now, what is the voltage passing through resistor 1? So the voltage passing through resistor 1 is 24. Remember, we said voltage is constant. So I'm going to say current 1 is equal to voltage is 24 over the resistance is 6. If you divide these two numbers, you get 4. The units for current are 4 amps. So from a certain amount of current, 4 amps went in this direction. Now let's find the current that went in the other resistor. So I'm going to use the same formula, but this one will be my current 2. So current 2 is equal to voltage divided by resistor 2. So what is the voltage in this direction is still 24. So I'm going to say 24 divided by 4. So current 2 is equal to 6 amps. So this is my 6 amps. Then if we have the current across each resistor, what is the total current produced by the source? So total current IT will be current 1 plus current 2. So total current will be current 1 is this number, 4 amps, plus this one, 6 amps, which is adding up to 10 amps. Then if we want, we can find the same total current using the total resistor. So we're going to say current, which is now, I'm not going to say current 1, but this time I'm just going to say total current is equal to voltage over total resistor. So for this one, make sure you use the total resistors. So voltage is still 20 over the total resistance is this one, 2.4. So if you divide 24 by 2.4, you still get 10 amps. So this is how we can deal with the current. Now let's look at the relationship between current and resistance. So if you look at the resistor 1 is 6 ohms and resistor 2 4 ohms. So resistor 1 is greater than resistor 2. Now if you look at current that went through resistor 1 is 4 amps, but in resistor 2 was 6 amps. So you can see that current and resistors are inversely related, because the resistors with the greatest resistance will allow a small amount of current to pass through, while the resistance with a smaller resistance will allow a much greater current to pass through. We've seen by calculation, because we can see where there is 4 ohms, 6 amps C was there. Where there is 6 ohms, 4 amps C was there. Now away from there, let's find the power. So say power 1. So the power for, we'll say power 1 for resistor 1. So I'm going to say power is equal to voltage times current. And we know that voltage is equal to current multiplied by resistance. So where there is a V, we can substitute with IR. So our new formula will be IR times I, which is power can be found as I squared times resistor. So let's find the power for this branch here. So power will be, what's my current? Current is 4 squared times resistance is 6. So power 1 is equal to 4 squared is 16. 16 times 6 is 96. So I'm getting 96 watts as my power 1. If I want, I can also find the same number by using this formula, voltage times current. So if we use this one, our voltage, remember, is 24 times the current is 4. So if you multiply 24 times 4, you still get the same number, 96 watts. Now let's find the power in this part here. So I'm going to use the I squared times R. So power is equal to, the current there is 6 squared times the resistance is 4. So 6 squared is 36 times 4. I'm getting 144 watts. If you want, we can say power is equal to voltage times resistance. So power is equal to, not voltage times, but voltage times current. So voltage is 24, current is 6. 24 times 6, I'm still getting the same number, 44. So we can now find the total power. So PT is equal to power 1 plus power 2. Power 1 is 96 plus 144. So 144 plus 96, I'm getting 240 as my total power. But if I want, we can find the total power. So total power is equal to voltage times current. So you use 24 volts multiplied by the total current is 10 amps. 24 times 10 is 240 watts. Now let's have the last example. So the last example, we are going to deal with now a circuit with 3 resistors. So now let's use a different electrical symbol for resistors. So this time we have 3 resistors. So our voltage source is 20 volts. Then resistor 1 is 2 ohms. Resistor 2, 4 ohms. Resistor 3, say 5 ohms. So the same, we are going to answer the same questions that we did. So we need to first find the total resistance. So I'm going to say 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R2 is equal to 1 over resistor 1 is 2 plus 1 over 4 plus 1 over 5. Lowest common denominator is 20. So 2 into 20 is 10 times 1 is 10 plus 4 into 20 is 5 times 1 is 5 plus 5 into 20 is 4 times 1, 4. So if we add 10 plus 5 is 15 plus this one is 19 over 20. So if we cross multiply, we are going to have 19 RT is equal to 20 over 19 over 19. So what's our RT? So 19 into 20, getting 1.05 amps. Okay, now let's find the same answer, but we are going to use this formula now. RT is equal to resistor 1 times resistor 2 multiplied by resistor 3 over the sum of the 3 resistors. So resistor 1 is 2 times 4 times 5 over 2 plus 4 plus 5. So 2 times 4 times 5. So 2 times 4 times 5, I'm getting 40 over. Okay, so when there are 3 resistors, see, let's not do this. So when there are 3 resistors, see, you do this. You say RT is equal to, you multiply. So say R2 times R3 plus R1 times R3 plus R1 times R1 times R2 over, why am I saying this? So on top we need to have R1 times R2 times R3 over R2 times R3 plus R1 times R3 plus R1 times R2. So let's see if we can have the same value. So this will be 2 times 4 times 5 over resistor 1. Resistor 2 is 4 times 5 plus 1 times 5 plus 4 times 5. So RT is equal to, on top we are going to have 2 times that is 8 times that is 40 over 4 times this one is 20. So here we should have, so this should be 2 times 5, then 4 times 2. So 2 times 5 is 10 plus 4 times 2 is 8. So we have 40 over 10 plus 20, 30, 38. So let me punch this one on my calculator. So 40 divided by 38, 1.05. So 1.05 ohms. I mean, this should be ohms, yes. So as we can see, we are getting the same value. Now let's move on to current now across each resistor. So let's put our total resistors here. We may need it later. So now we are going to consider this one as our current one. So current is equal to voltage over resistor 1. So voltage will be 20. So 20 divided by 2, so the current is 10 amps. So here the current one will be 10 amps. Now let's focus on current 2. So current 2 will be voltage over resistor 2. Voltage is still 20 over 4. Here we are going to have 5 amps. Current 3 will be voltage over resistor 3. 20 over 5 giving us 4 amps. Therefore, total current is equal to current 1 plus current 2 plus current 3. Current 1 is 10 amps plus 5 amps plus 4 amps, giving us 19 amps. So 19 amps was produced by the source. Then from that 19, at this junction, 10 went in this direction. So we are going to have 9 amps here. At this direction, 5 amps went in this direction. So 4 will go in this direction. So this is the 4 amps at this point, according to the Kirchhoff's current law. Then we can also find the same total current is equal to voltage over 1.05. So voltage over total resistance. So voltage is 20 over 1.05. So 20 divided by 1.05. I'm getting 19.04. So 19 amps. As we can see, we are still getting the same value. So I give you now the task. You can find the power 1, power 2 and power 3 and send your answers in the comment section below. So that's it for this video. Thanks for watching and have a good day.